Alright everybody, what is going on? This video we're going to look at the derivative, and we're going to take derivatives using the definition. This is the long process of taking the derivative. Now let me say this, it's something you got to learn, something you're probably going to be tested on. You may have one problem or so, but on your test on finding derivatives like this, but you know, after you work that problem on the test, you're probably never going to do this again. Okay, but you know, you got to learn it. All right, so for a function f of x, the derivative is f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. You might recognize this f of x plus h minus f of x over h. This is a difference quotient. And all we're doing is we're taking the limit as h goes to 0. Okay, so just real quick, let me show you this. So if you've got 2 points here, and this is x, and then you move over to this x value, and let's just say you move over h units, then this would be x plus h. So the coordinates of this point would be x, f of x, and the coordinates of this point would be x plus h, f of x plus h. And so what you've got here, if you look at the slope of this line, remember the slope of a line if you're given 2 points, it's y2 minus y1 over x2 minus x1. And so this is actually equal to f of x plus h minus f of x. And you see the x's cancel out, and you're left with h in the bottom. And so basically what we're doing, the distance between these two x values, we're making that go to 0. See, h is going to 0, so that distance there is getting smaller and smaller. All right, now let me show you this real quick before we move on. Now, the notation for derivatives. So here's some notation for derivatives. Most of the time you're probably going to be using like f prime, y prime, stuff like that, dy dx. But some notations are y prime, and then derivative of y with respect to x, f prime of x, and dy dx. These are just different notations of how you can represent the derivative. Now, the most common ones are probably going to be this one, and then you'll see this one some also. Now, this one, I mean, are you going to see it? Yeah, probably, but as far as this course goes, you're not going to see it that often. You'll see it in differential equations, stuff like that. But yeah, that's the different notations. I will use f prime and y prime mostly. All right, so let's get started and look at some examples. So here they want us to find the derivative. So we have f of x is equal to 2x squared plus 3x. And so the derivative f prime of x is equal to the limit as h goes to 0. Now, let's go through this problem slow on how we're plugging things in, and we'll move a little faster on the other ones. So think about this. If I asked you to find f of, say, 3, okay, what would you do? You would take the 3 here and plug it in for x. So that would give you 2 times 3 squared plus 3 times 3. And you can see what we've done here is we replaced the x values with 3. Well, that's all this f of x plus h is. This part right here, this is just telling us to replace each one of these x values with x plus h. So let's do that. So that's 2 times x plus h squared plus 3 times x plus h. All right, so there you go. This right here is your f of x plus h. All right. All right, and then what do? Minus the minus sign here, f of x. Well, what's f of x? Well, f of x is just this. This is 2x squared plus 3x. Now, the one thing that you do not want to forget is it's minus f of x. So it's minus this whole thing. So that needs to be in parentheses. All right. And this right here is your f of x. And then all of that is divided by, we got the division, divided by h. And there you have it. So we've got all of it plugged in. And now we just got to simplify. Now, what do we need to do to simplify? Well, just keep this in mind when you're simplifying it. You see this h right here? This h? You want to cancel that h out. That's what you're trying to do. We got to plug 0 in, and we don't need 0 in the denominator. So we need to cancel that h. So let's see what we can do here. So this is equal to the limit as h goes to 0. And this is going to be 2 times x squared plus 2xh plus h squared. All right. So what did I do there? What did I do there? Well, this right here, I just multiplied that out. Remember, excuse me, remember, x plus h squared is what? X plus h times x plus h. And I just multiplied that out. And then I've got 2 times that. And then plus, and then that's going to be 3x plus 3h, distribute the 3. And then I'm going to distribute the negative, 2x squared minus 3x, and all that over h. Now I've got to do another step to distribute that 2. That's all I'm going to do in this next step. So that's limit as h goes to 0, 2x squared plus 2xh plus 8. Look at there, I messed up, didn't I? Plus 4xh plus 2h squared plus 3x plus 3h minus 2x squared minus 3x, all that over h. And now all we're going to do is combine like terms. So look at this. The 2x squareds cancel out. The 3x's cancel out. And so I'm left with the limit as h goes to 0 of 4xh plus 2h squared plus 3h over h, which that's the limit as h goes to 0. Now look at this. You see how I have a common factor of h? So I'm going to factor out the h plus 2h plus 3, all that over h. And look at that. The h's cancel. And so I'm left with the limit as h goes to 0 of 4x plus 2h plus 3. And now I just evaluate the function here at 0. So that's going to be 4x plus 2 times 0 plus 3, which is 4x plus 3. And there's your derivative. Now, let me say this. Some problems, you'll have to evaluate the derivative at a point. So they could say, find f prime of, say, 2. Okay? And if they want you to find f prime of 2, what I would recommend doing is find the derivative just like we did. And that's this. So we have f prime of x is equal to 4x plus 3. And what did they want us to find? They wanted us to find f prime of 2. So now, once you find the derivative, now evaluate it. So that's 4 times 2 plus 3, which that is 11. Okay? I know the problem didn't ask us to do that. I added it. So now you know how to evaluate the derivative also at a particular number. All right, so let's look at this one. So we've got y equals 6x minus 2x cubed. All right, so let's go ahead and find the derivative. So I've got y prime is equal to the limit as h goes to 0 of 6 times x plus h minus 2 times x plus h cubed. All right, there's your f of x plus h right there. That's this. Well, and in this case they use y, so this would be what? Y of x plus h. You know, whatever variable they're using. Okay, and then that's minus y of x, or y, however you want to put it, but that's just the 6x minus 2x cubed, and that is over h. And this is your y, or your y of x. Okay, now, you know, just keep in mind in the formula up here, it's f of x plus h minus f of x. You could have y of x plus h minus y of x. Okay, same thing. And you might even see sometimes s of t plus h minus s of t when you're talking about displacement and doing velocity and that kind of stuff. And that we'll talk more about stuff like that in another video. All right, so, well, it looks like the most difficult thing we have to do here is this x plus h, multiplying that x plus h cubed, doing that. So what I would do is I would go off to the side, and what I'm going to just come down here and do it. So, you know, I'm going to do this in a slightly different color to just let you know this is something I'm doing off to the side, and then once I get the answer, I'll just put it in there. Because see, what I need is I need y prime is the limit as h goes to 0 of 6x plus 6h minus 2 times, and now I need that x plus h cubed. All right, so let's do that. So remember, that's x plus h times x plus h times x plus h. And so what do we get here? Well, we get x squared plus 2xh plus h squared times x plus h. So this right here came from multiplying those two together. And I get this. And now I have to multiply it to that. So I'm going to take the x, multiply it times each term, the h, multiply it times each term, and then combine like terms. All right, so this is going to give me x cubed plus 2x squared h plus xh squared plus x squared h plus 2xh squared plus h cubed. And does anything, let's see, make sure I did that right. X cubed to xh squared. Wait a minute. X cubed 2x squared h xh squared, and then I've got x squared h. Okay, all right, so I've got x cubed plus, let's see, 2x squared h, that's 3x squared h, and then I've got an xh squared and a 2xh squared, so plus 2xh squared plus h cubed. All right, so I multiplied that out. So now I can just copy that right here. So that's going to be x cubed plus 3x squared h plus 2x h squared plus h cubed. All right. Minus, I'm going to distribute the negative, so minus 6x plus 2x cubed, all that over h. All right, so now I can erase this. You know, you might need to do that sometimes like I just did there. Just go off to the side and, you know, do your algebra. All right, so this is going to be the limit as h goes to 0. Now what I'm going to have to do here is distribute the 2. So that's 6x plus 6h minus 2x cubed minus 6x squared h minus, oh, wait a minute. I think this should be a 3 right here. 3xh squared. Yeah, for some reason I wrote a 2. That should be a 3. So minus 6xh squared minus 2h cubed minus 6x plus 2x cubed, and all that over h. All right, so we get the limit as h goes to 0. Now let's see what cancels out. The 6x cancels out. The 2x cubed cancels out. And so I am left with, let's see, 6h minus 6x squared h minus 6xh squared minus 2h cubed, all that over h. All right, so look at this. We've got the limit as h goes to 0. I can factor out a h. H times 6 minus 6x squared minus 6xh minus 2h squared, all that over h. And the h's cancel. So I'm left with the limit as h goes to 0 of 6 minus 6x squared minus 6xh minus 2h squared. And so that's going to be 6 minus 6x squared. I'm just plugging the 0 in for h. Minus 6x times 0 minus 2 times 0 squared, which that leaves me with 6 minus 6x squared. And there's your answer. So, you know, it's a lot of work. But what you're really going to like is when we get into some later videos, we're going to have rules for finding derivatives, which this problem here, you can just do it in one step. You can just write the answer down. Some of you probably already know how to do it, some of you not. But just remember, you're probably going to have to do one of these. Okay, I know if you're in my class, you're going to have to do one problem like this on the test. All right, so let's look at the next one. All right, so we've got y prime is equal to the limit as h goes to 0. Now that's going to be 1 over x plus h. It's f of x plus h, or in this case we've got a y, so y of x plus h. So I'm going to put x plus h in for x, minus y of x. Well, what's y? It's 1 over x, 1 over x. And then all that divided by h. So this is my y of x plus h, and this is my y of x. All right. And now comes the part where, you know, some of these can be difficult to simplify. This one's, I guess you could say, is kind of one of them. It's not that bad, but look at it like a complex fraction. You probably remember that from algebra. You got a fraction. Say we got a fraction in the numerator, fraction in the denominator. We can look at that h as h over 1. And what I want to do is I want to look at this denominator, and this denominator. and I want to get a common denominator. And what do I want to do with that common denominator? Well, I want to multiply each term times the common denominator. So what's the common denominator? It's x times x plus h. X times x plus h. X times x plus h. So all I'm doing is I'm multiplying each term times the common denominator. That's all I'm doing. All right. And so what that does, look at this. It cancels an x plus h. Here it cancels an x. And so I am left with the limit as h goes to 0 of x, see the x times 1, minus, and then 1 times x plus h. So that's 1 times x plus h. And we can put the 1 there if it makes you feel better. And that's hx times x plus h. All right. So what it's done is it gets rid of the fractions for you. And now it makes it easier to simplify. And so now we have the limit as h goes to 0 of x minus h over hx times x plus h. I just distributed the negative 1. And so this is the limit as h goes to 0 of negative h over hx times x plus h. All right, so remember what I said at the beginning of the video. What are we wanting to do? We're wanting to cancel this h out of the denominator. And you can see, there you go. There they cancel. So limit as h goes to 0. And I'm just going to write the negative out front here. Negative 1 over x times x plus h. All right. And so now that's going to give me negative 1 over x times x plus 0, which is negative 1 over, what is that? That's x. X times x is x squared. And so there's your derivative, negative 1 over x squared. All right, so let's look at this problem. This one doesn't look fun to do, does it? We've got an x squared and we got a 1 over x plus 1. So, well, let's just go ahead and dive into it. And and to tell you the truth, I've never worked this. I don't think I've ever worked this problem. So this one's new to me also. So I have f prime of x is equal to the limit as h goes to 0. And so that's going to be x plus h squared plus 1 over x plus h plus 1. All right. There's your f of x plus h right there. This part right here. This is f of x plus h. All right, we replace this x with x plus h and this x with x plus h. And then that's minus f of x. Well, what's f of x? It's this term right here, or these two terms here. So that's x squared plus 1 over x plus 1. And that's all in parentheses. It's minus the whole thing. And then that's over h. All right, so what do you think we might want to do now? Think about that for just a second. I think the best thing to do would be to distribute this minus sign here and multiply and FOIL that out. And so that's going to give me the limit as h goes to 0 of x squared plus 2xh plus h squared plus 1 over x plus h plus 1 minus x squared minus 1 over x plus 1. And that's all divided by h. All right, so it doesn't look like it really helped a lot. I mean, but I guess it did. And we still got the fractions here. We gotta simplify that, because remember, what are we trying to do? Cancel this h out. And so this is the limit as h goes to 0. Now, I guess this might help a little bit. The x squareds cancel out. And I could skip a couple of steps here, but I'm not, because I don't want you to get lost. Okay, because I think I know what we're gonna do. So I think the best thing to do is maybe split this up. I can take the limit of each term individually, but we need to split it up. And I think what I'm going to do to split this thing up is I'm going to do the limit as h goes to 0 of 2x h plus h squared over h plus the limit as h goes to 0 of 1 over x plus h plus 1 minus 1 over x plus h, and all that over h. So I think I'm going to split it up like this, like into two separate problems. And so this one right here, this one's easy. We can just factor an h out and we're ready to go. Now what about this one? I need to simplify this. Well, if you think about it, it kind of looks like this last problem that we did, doesn't it? You see that? Where we just get a common denominator and multiply each term by the common denominator. So I think that's what we'll do here. So look at this as h over 1. And now what I want to do is multiply each term over here times the common denominator. And so that's x plus 1 times x plus h plus 1. And this is x plus 1 times x plus h plus 1. And then multiply this one times x times, why did I write x? X plus 1 times x plus h plus 1. And we can see here that the x plus h plus 1 cancels, the x plus 1's cancel, and nothing cancels there. And keep in mind that's over 1 multiplied to that h over 1. And so this is going to be the limit as h goes to 0. Now I'm going to go ahead and factor an h out of the numerator here over h. And you can see those h's will cancel. And then I've got plus the limit as h goes to 0. So I've got x plus 1 times 1, so that's x plus 1, minus, and then I've got, what am I left with? X plus h plus 1 over h times x plus 1 times x plus h plus 1. All right, so I think this is going to work out pretty nice here. And so you can see the h's cancel, and we're left with the limit as h goes to 0 of 2x plus h plus the limit as h goes to 0. Now look at this. I'm going to distribute the negative. So x minus x is 0, and then I've got negative h. You see that? And then 1 minus 1 is 0. So the only thing I'm left with in the numerator is negative h. And then that's h times x plus 1 times x plus h plus 1. And then we've got the limit as h goes. Yes, I could go ahead and take the limit, but I'm just going to wait and take the limit of both of them at the same time. And then you can see here, look at that, the h's cancel. And so that's going to be the limit as h goes to 0 of negative 1 over x plus 1 times x plus h plus 1. And so now we get 2x plus 0, and then we can just put the minus, and then 1 over x plus 1 times x plus 0 plus 1. And so this is just going to be 2x minus, now look at this, this is x plus 1 right here, right? X plus 1. So what's x plus 1 times x plus 1? Well, x plus 1 squared. And there's no need to multiply that out. Just leave it as x plus 1 squared. If you're in my class, leave it like that. I don't know what other teachers tell you to do, but I would suspect that they tell you to just leave it as x plus 1 squared. Don't multiply that out. Okay? But yeah, there's your There's your derivative. All right, so let's look at this one. And this is the last one right here, the square root of x. Now, I want you to keep in mind, not only are you learning to take the derivatives, but you're actually learning some more techniques on finding limits too. All right, so we've got y prime is equal to the limit as h goes to 0, square root of x plus h minus the square root of x, all that over h. So hopefully you can see that. That's, well, we're in terms of y, so y of x plus h, and this is y of x. All right, so, well, we've got to get rid of that h down there in the denominator. So what in the world are we going to do there? Well, do you remember in algebra, you would have something like this, 2 minus square root of 3. And what would you do? You would have to rationalize the denominator. You would multiply numerator and denominator by the conjugate of the denominator. Okay? Well, in calculus, what we're going to do, what you'll do some, is rationalize the numerator. So what we're going to do here is we're going to multiply numerator and denominator by the conjugate of the numerator. All right. And the one thing that I want you to understand here is this part right here. This is like a minus b times a plus b, right? And that's equal to what? A squared minus b squared. You see that? And you can see in our problem, a is the square root of x plus h, and b is the square root of x. All right. And so what do we get when we multiply that? Well, that's the limit as h goes to 0, and that's a squared minus b squared, okay, all over h. Whoop, I'm sorry. All over h times square root of x plus h plus square root of x. All right. And so this is going to be the limit as h goes to 0 of square root. That square root symbol is gone. X plus h minus x over h times square root of x plus h plus square root of x. And you can see here how the x's cancel out. And so that's going to be h over h times square root of x plus h plus square root of x. And look there, it worked out for us again. The h's cancel. So I'm left with the limit as h goes to 0 of 1 over the square root of x plus h plus square root of x. And now we can plug the 0 in for h. So that's 1 over the square root of x plus 0 plus the square root of x. And let me just write this step out. Square root of x plus square root of x, which is 1 over 2 square root of x. And there's your answer. Now, the next thing you might be thinking on this problem is, do I need to rationalize that denominator? And, you know, my answer, no. Don't worry about rationalizing the denominator. Just leave it as square root of x. Now, you know, that's for my students. But your teacher may tell you to rationalize it. But I'm guessing a lot of them are probably going to tell you just to leave it like this. Okay? So that's finding derivatives using the definition. Like I said, you're not really going to use this. You may have a problem. You have to work on the test. You will if you're in my class. But yeah, that's it. That's the video. That's finding derivatives using the limit. So I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see y'all in the next one. Later.